All right, so we're going to be starting off with section 1.1, modeling and solving equations. This is basically what math is about. This stuff right here. Out in the real world, you gather data, you organize that data in a different formats, and you try and find a model, which is a rule or an equation that mimics it, and then use that model to predict what might happen past the data points that you have, or you can infer information from data in between data points that weren't gathered. So there is basically there's more, but there's three modeling types that we look at. Okay, there's the mathematical model. Let's look at that. We'll define that real quick. The mathematical model, and you know what? I'm going to do it this way. It is a mathematical structure that approximates phenomena for the purpose of study or predicting their behavior. So, mathematical models, that's what we're looking for. This is what math is really about. Okay? This is what you'll do in the real world. And we're going to look at these things in three different types. The first type is the numerical model. The numerical model is a model in which the numbers or data are organized to gain insights into whatever it is that you are looking into. We predominantly use a table to organize our data. So think of that as the table kind of thing. The algebraic model, this is the one where we're using formulas to relate the quantities associated with the phenomena that you're studying. Okay, that's where you write your equation that mimics it. And then the last one is the graphical. This is the visual representation. We can represent the numerical data by putting a bunch of dots and seeing what kind of pattern is emerging. We can use the algebraic model. We can graph the equation that we have, and we can graph them both at the same time, the numerical and graphical, and see how they relate to each other, if it's a good fit or not fit, and all that kind of stuff. So we are going to focus on these three model types. So when we do a problem, you're most likely going to be doing all three in some fashion. Okay. So this course will explore how all three of these models can be used to solve problems. And so here's an example of how all the models can come together in one problem. And so I want you guys, I'm going to bring this over here. We're going to look at, in your textbook, you can go ahead and take a look at problem number 23. So this will be on page in your textbook. Let me get to it real quick. I forgot to write the page number. On page 74. So if you take a look at it, I'll go ahead and kind of show you what I have right here. Okay, so a physics student obtains the following data involving a ball rolling down an inclined plane, where t is the elapsed time in seconds and y is the distance traveled in inches. And you can see that the data was given in a numerical table. And they want us to find an algebraic model that fits the data. So this is the problem, okay? So I'm going to move this out of my way again. Since they gave us the data, but you can see the data was already organized. So the numerical model is already there, okay? They gave it to you already in the form of that table. So reproducing the table real quick. We have t, we have y, we have all these times. And then we have the data that's associated with it. And this was 19.2, and this is 30. Okay? What we can do with this table right here, the data, is we can actually grab our calculator, and we can enter the data into this calculator. Okay? I'll do this a little bit later because I don't want to go into that right now. And we can graph these dots in the calculator. and we can see what happens, okay? I'm going to do a rough sketch. Normally I'll do a much nicer sketch, but I'm going to do a rough sketch here for you. In doing so, it would look like this. So we'd have down here would be in time, and that would be in seconds. So when you draw graphs like this, you have to identify what each axis represents. This is the distance in inches that the ball rolls. Okay, and we had some time here from 0 to 5. So 1, 2, 3, 4, 5. The heights go from 0 to 30, so we need to have some numbers over here to go up to 30. Where did I go back? So this is 30. This is 3, 6, 9, and so forth and so on. So in graphing this, we have a 0, 0. So you just have it. You'll have a dot here. At 1, it's 1.2, which is about here, and 2 is 4 something, so about here. And this keeps on going. 3 is at around 10-ish. 4 is around 19, so that's probably right about here. I'm just ballparking here, guys. And 5 is up here at 30, so right about here. So that's the data graphed out. This is a graphical representation of the numerical data. So the next part we do is, once we see this, is there a pattern? Is there some curve that might mimic this that we can find? So this is why we do this, to see what kind of patterns we can see. And then from our knowledge that we're going to gather and gain throughout this course of all the different types of functions out there, if you don't remember them all, we find one that kind of fits this the best. Our calculator can do this for us. And again, I will go into all that a little bit later on how to actually use the calculator to find the one that fits this the best. Okay. But there is one. You can look at here and look for patterns in this and see if there's any kind of pattern that might help me determine which one it is. But this shape right here kind of matches a couple of different types of functions that are out there. If you don't remember what they are, one would be like a polynomial. Okay, polynomials kind of curve, right? This could be like a vertex down here. It could be a parabola. It could be a cubic, so kind of could do this kind of a thing. I don't know. It could be any one of the parabolas, the polynomials that are out there. It also kind of looks like it might be exponential, but I don't know. I mean, we can take a look and see if it might, but in this particular case, we can do a curve fitting on this thing. And if we did, what you would get is a curve that goes through here, kind of like that, fits it kind of nicely, and it would be the equation. So my algebraic model, and we can find this on the calculator, would be 1.2 times t squared. So if I took 3 and I square, I get 9. Take 9 and times it by 1.2, I get 108. Okay? And you can try it out. It should be pretty close to 108. 10.8. And this would be the algebraic model that we determined from our data. And the visual representation helped me narrow down a choice. So that's a lot of what we do. So when we do a problem in here and solve problems, you need to present your solution, not just get an answer. Your solution is numerical model, algebraic model, visual graphical model. You need to display in those 3 fashions for the most part when we solve word problems and such. Okay? If we're doing just skills, then you just do whatever skill they ask you to do. So the next thing I want to talk about that goes off of the same kind of thing, and I'll have you use the calculator with this a little bit too, is what does it mean when we say in problems that you've done before, find the solution or solve the equation? What does that mean? Okay? And so hopefully you kind of remember from your algebra 2 days, but you may not. I'm going to have you work along with me on this one, but so you can see this equation. Okay. So here's an equation. It is a quadratic equation. Okay. Again, you can do a numerical solution for equations. They're a lot more challenging to do it that way. So we don't really solve equations numerically. What I mean by numerical in this one, if you're trying to solve an equation numerically, it basically means guessing and checking. Okay? But educated guessing and checking. And that takes a lot more work. So we don't do that. We usually refine ourselves to solving in an algebraic fashion, if possible, and or a graphical, depending on the situation and our needs. Doesn't mean we have to do them both all the time. Okay? Just means you do what fits the needs that you may have. So algebraically, this right here can be solved by factoring technique. Since it's quadratic, you can use the quadratic formula. Factoring technique is faster, and you should learn it if you do not know it. Hopefully you do know it. So if I have x squared minus 5x plus 6 equals 0, then this will factor into two binomials, still equal to 0. And as such. And then by the zero product property. Okay, so from algebra 1 and algebra 2, if you remember this, we do this, and then we take each of these things and we set them equal to 0. And the question then, a lot of times people don't really know why they're doing that. Well, that's what this property here is saying. Okay, the zero product property says if two numbers, see this is a number and that is a number. If two numbers multiply and equal 0, one of them has to be 0. There's no other way. So which one is 0? Well, this one could be 0, or this one could be 0, or they both could be 0. Okay? So what value of x makes this one 0? So then we solve for the value that makes that one 0. And you get x equals 2, and then over here you'll get x equals 3. And so these then became what we called solutions to this equation. Okay? That's where these words come from. In a graphical sense, and I'm going to make this fairly quick. So here's 1, there's 2, there's 3, there's 4. What this is saying when we said these are my solutions, because these are the values of x that make this quantity a 0, or this quantity is 0 for that one. When I graph it in a table setting, what you're saying here is, if I plug in 2, I'm going to get 0. If I plug in 3, I'm going to get 0. So in the graph, we have those two things right there. We can graph the rest of the same because we can see that the y-intercept is up here. If I plug in x to 0, we get y-intercept at 6. So real quickly, I'm going to sketch this. It looks something like this. And then it comes off like that. It's ugly, but that's basically the idea. Okay? And then you can see that these solutions, which produce an x-intercept of these values, the solutions are the x-intercepts. And this is one of the key things that you learned, hopefully, in Algebra 2. And so here are some fundamental connections that we want to make sure we understand. Okay? This will all be reiterated again later on when we get into Unit 3, but that's what this is going on in Unit 3. So, and I'm just going to throw it over here so you can see it, so I don't have to write it. I'll zoom it in so you can see it. What connections can I make from all this? What do I need to take from here? It says, if k is a real number. So k is just some number right here. These 3 and 2 would be considered the k's. Okay? If they is a real number and it solves this equation. So in other words, these two numbers are the solution to this equation over here. That's what it's saying. Then all 3 of these statements are the same. They're all the same. That means if I have one, I have them all. That's what it means. K is a solution of the equation. 2 and 3 are the solution to this equation. K is a zero of this function. In other words, if I take this number and plug it in to that, I get a zero. That's what it means, a zero of a function. Function is not an equation, it's just a function. It's the name, it's the picture. And K comma 0 in a point format is the x-intercept of the graph. You see how everything is connected here? That's the major thing that you need to understand, okay? So when you solve this equation, this quadratic equation, you found these numbers. Those numbers were the x-intercepts of the graph, but they're the solutions to the equation. Okay? So, does this continue on? So, we're going to use that concept throughout this entire course. Okay? X-intercepts are solutions to certain equations and stuff like that. And here's another example. If you want to play along with me, you can. This is problem number 36 from your textbook. It says to solve algebraically and graphically. Algebraically means we're going to try and solve it, without, it's like using all the special techniques that we've learned. And graphically means we're going to be having to graph at the end in some fashion. Okay. Now this one I am going to walk you through. I'll grab my calculator real quick. The technique I'm going to show you for solving graphically is a very fundamental technique that we will use it here extensively. So when we get to that one, I'll show you what I mean. So here is the problem. We need to solve this algebraically. Now, how do I do that? Okay, you may or may not remember. If you don't, it's no big deal. You just need it. There are squares in here. That means it's a polynomial. That means it has to be everything on one side equal to 0. Okay? When in doubt, put everything on one side and make it equal to 0. If you don't know how to solve it, everything to one side and make it equal to 0. Regardless of what it is. Okay? How should I move it? Any way you want. Doesn't matter. I do recommend, because this is a squared and this is a 2x squared, that you move things so that the highest exponent term is positive. I do recommend that. Okay? Doesn't mean you're wrong if you don't. It just means you're making more work for yourself. So instead of moving this one over here, move this one over here by adding the opposite. So that means everything's going over there. So I'm going to subtract that. I'm going to add that. I'm going to subtract that. And then line it up under the respective thing. So we have a plus 3x here. And then we have a minus 4 here. So what I get done, this side is 0. That is x, because 2 minus 1 is 1. Negative 7 and 3, minus 4, minus 12. So I have this quadratic right here. Since it's a quadratic, I can solve using quadratic formula or factoring technique. If you can factor it, do so. It's much faster. I got x and x, 6 and 2, minus plus, and there you go. Just like before, what makes these 0? Because it's a product that's equal to 0, so one of them has to be 0. So that means this one can be 0 or that one can be 0. So the solutions become 6 or they become negative 2. This is your algebraic solution. Okay? Now, graphical. How does that work? Okay? How do I do a graphical solution on the calculator? Because that's really why you're doing it. You don't want to solve it, you don't have time to solve it algebraically, but you just want some answers really quickly. Can I do it on the calculator and solve it? Yes. Okay? And you can get the actual answers If it's not a nice one, it'll be in a decimal format though, okay? So I don't know how familiar you are with the TI Inspires, okay? But go ahead and turn them on. So you want to see that screen right there? Some people play over here in the sketchbook, the sketchpad area, the calculator and graphical sketchpad. I don't recommend it. You can if you want. I mean, it'll do stuff for you. I like to go over here and just create new documents. So if you will, just go ahead and highlight and enter on the new documents. Use your arrow keys to move around, push the center to select, or you can just hit the number 1 and it'll go to a new document. And this may pop up. You want to save. The answer is always no. Never save anything. It just clutters the calculator up and makes it stop working properly, okay? So just hit no, and now you have a choice. Well, what kind of document do you want to have? This one has, you can see, 7 different things we can do. So each of these little documents is like something like, you can do an Excel spreadsheet, you can do a graphing thing, you can do a calculator thing, you can do all that kind of stuff. But we want to do a graphing. So we're going to do a graph, so you can either go down to number 2 with the arrows, these will move you around, and then you enter the center, or you can just hit the number 2. And there it goes. It gives you a screen with the X and Y axis. You'll have a function line. Mine's on the bottom. Yours should be at the top. Okay? So, how do I do this? Well, there's 2 methods that you can do to solve graphically. Number 1 is kind of what we did right here. I had this equation up here, and I moved everything to one side, and I set it equal to 0. That's basically what happened. Once you have done that, you can graph that right there and look for the x-intercepts. You can graph that and look for the x-intercepts. So let's graph that. So you just type it in. This is your squared button right here. The x is the x button down at the bottom. Okay. So you just simply type in x squared. Make sure you're not up in the exponent anymore, but for squares, I think it defaults. You can't really see what I'm typing, sorry. But kind of watch that little blinking cursor. See how it's the whole side, so just you can use the arrows to move out of the way. You got minus 4x minus 12. And once you have it typed in there, you hit enter, and it will graph it for you. So you'll get to see some part of it. It's a standard window, so you can modify the window scale to see the graph in its entirety. But all we're really interested in is, where are the x-intercepts? The answer should be at 6 and at -2. If you look at this calculator, you can see that you're at, one's at 6 and one's at -2. Yes? Okay. So, but what if it wasn't nice and neat like that? How do I know it's not 6.01925? Right? I'm not going to be able to see that on a calculator with that big thing. So how do I know? How do I actually do this? Now, I know you're not going to remember this technique, but it is going to be in the video, so you can always come back and kind of find it in here. How do I find an x-intercept on this calculator? In this graphing screen, there's the button menu. Okay, so you hit menu. I know you can't really see it here, but the options that I have might be slightly different than yours. But there's one here called Analyze Graph. This is your go-to button, Analyze Graph. Okay, changing the view and the window and the analyzing the graph and trace are your major things. So we're going to go to number 6. The new window pops up, and over here are all the things you're going to do in here. We're going to find the zeros, which is what we're going to do right now, maxes and mins, and intersections. Those top ones are what we are going to use in here extensively, okay? For right now, we're going to do zeros. So you click on 0. And you're going to see that this little hand thing pops up with a little finger pointing up. And if you use the arrow keys, you'll see a dotted line is moving with it. Okay? So down here at the bottom, you'll see it says lower bound. What you want to do is you want to move this dotted line so that you are right next to, on the left of the what looks like the x-intercept. You don't have to be, don't get too far away, but you don't have to be right up next to it. I mean, see how far I am from it here? I could stop there if I wanted to. See, I'll just hit enter, and it'll put a mark there or a boundary there. Okay. Notice that now, if you look here, you'll see it changed to what's the upper bound. And what they want you to do there is they want you to move that little line or to the other side of where the x-intercept looks like. And look what happened. See how that dot popped up? I don't know if you can see it. See the dot popped up right there? So what it's using is a mathematical technique called intermediate value theorem. And it's finding that dot for you as you move the thing across. Hit enter, and it solidifies that 0. And you can, the hand pops up like that. You can hold down the center, it grabs it, and you can move it off to the side if you can't read it. And then hit the middle again, it'll let go. So where is that x-intercept? At 6, 0. So that is your 0 right there, confirmed on the calculator. So this is how you find zeros on the calculator. That technique is very similar for finding maxes and finding mins and finding intercepts. It's literally the same technique. You're just going to do it for each individual one. That's method 1 for this. Everything equal to one side, so it's equal to 0. Look for the zeros. But what happens? What's the downside of that? Well, what if I move this wrong? What if I move things to the other side incorrectly? Made a slight addition error. Okay? Messed up a sign. Well then, yeah, I'll get answers, but it'll be wrong, won't they? So is there a way I can do that without having to do that? And the answer is yes. It's method number 2. Okay? This is what I usually use, method number 2. In method number 2, you don't move anything around. There are 2 sides of this equation. Each side has a polynomial or a function there. So what you're going to do is you're going to graph both functions on the same graph as 2 separate functions. You're going to graph the right side as a function, and you're going to graph the left side as a function. Let me show you how you do that. So let's open up a new doc. So if you look right here, it says plus page. That means I'm going to hit Control, and I'll hit Doc, and it'll open up a new page. See, 1.2. And I want this one to be a graph also. Going back to a clean screen now. I'm going to graph the left side right now. X squared minus 3x plus 4. X squared minus 3x plus 4. Type it in, hit enter. There it is. Okay. Then I'm going to get that entry back again. I have these little marks, these little things down here. If I go and click on that, I'll get the entry line. I think if you just hit enter or something, it gives you the entry line. I'm not sure though. We'll have to explore that because I can't quite remember. And now I'm going to type in the next one. I'm going to type in the right side. The first one was the left one. Now I'm doing the right one. I'm going to type 2x squared minus 7x minus 8. And I'm going to graph that one. And so there we go. So now both graphs are on the same screen. What I'm looking for here is when are they equal? Well, if they're equal, then they have to touch, don't they? So what I need to do is I need to move this around, change the window settings so that I can see the graphs and where they cross. Okay? You can move things around a couple of different ways. Number one, because I know the answers already, I can come up here, go to a blank area, get that hand, or just off to the side here. What I'm going to do is I'm going to hold the center button down until I see a hand that kind of looks like this, and it'll grab the screen like that. So I'm just going to hold down the middle. See that? See how it changed to that? It's like a hand grabbing the screen. Let go, and then I can just slide this pad down, and it's going to move the whole thing down. And if I can't see it, I can let go back up. At the top, do it again, and slide it all the way down. Okay? So you can see like right about there is where they're crossing, and right about there is where they're crossing. So that's one technique. Okay? Maybe not the best one, but it is one. Gives you some functionality of your calculator so you can move things slightly around. Okay? The other one, and probably the one you might want to use the most, is go into the menu. Right here, number 4 says window and zoom. Go into the window and zoom, and then I can change the windows that I want. So window settings is where I want to be. This is where I can customize it the way I want. If you do a zoom in or a zoom out, it changes both axes, and so it can get really small and you may not see things. But this one is the custom one, the number 1, window settings. If I select that, then I get to choose what I set my window at. So the first one is that you're going to do is the x-axis. What's the smallest x I want? What's the biggest x I want? Well, I already know that the 1, 0 is at -2, right? So maybe just type in -3, get a little bit below it. I know that 6 is the maximum 0 that I'm looking for, so go a little bit beyond that one. Maybe go to 7. Just gets rid of all the fluff. We saw when we graphed it that they're going to intersect way up there on the x-axis, correct? So when I go down here to the y-axis, just leave that as auto. I don't need a lot of y-axis stuff. I can just start it at 0. And I don't know where it is up there, so maybe I want to go a little high. It's at 23. Let's just go to 25 and see if that does anything for me. Okay? If you do all this and it doesn't work, just come back to the screen and readjust. Okay? When you're all done, go to OK. You can tab to get to where you want to go. Hit OK, and the screen is redrawn to that setting. And you can see that the intersections are a little bit easier to see now. So if I want to find that intersection right there, go back to that menu and analyze graph. Menu, analyze graph, which is number 6. And now we're going to be doing number 4, which says intersection. The 2 graphs are intersecting, so you're doing an intersection, number 4. And you'll see there's the hand with the dotted line, and it says lower bound. So slide it to the left of where the intersection looks. See? Hit enter. It changed to upper bound, so slide it to the right. Go past it, the dot will appear. Boom, hit enter, and there it is. So it intersects at 214. But what's the x value? 2. I'm sorry, -2. Okay, at -2, which is the answer we were looking for. So that's how I can do the solving graphically on the calculator. Again, referencing class, ask me, we can go over it many times. You can always come back to this video also and check this part out again. Okay? So there's that. Now, there are some problems and some hidden misleading information on the graphing calculator that a lot of times people do not recognize. So I want to point some of those out to you and do it fairly quickly here. So I'm going to open up a new screen, and I'm going to type in an equation for us so we can take a look at it. And minus 10x squared minus 18x plus 1. I graph that. And there you go. Typing the wrong thing. Well, it's not showing what I thought it was going to show. Well, I guess I had the wrong graph typed in here in my example. But what would happen here is like you're looking at this thing right here, and that looks like it might be a 0. That's 0. Kind of hard to see. So if you look closer here, looks like it might go through 0. Okay. So a lot of times we go, oh, it goes through 0. You can't say that. You don't know that it actually goes through 0 until you can confirm that it goes through 0. Okay. So you got to be careful of something like that. All right. Just because it looks like it does doesn't mean it actually does until you have confirmed it. Okay. So that's one thing that happens a lot. I'm going to open up another one. I'm going to type another one for you. Make sure I'm in the right mode here. A second. Yep. If you look closer to that, see? If you look closer to that, it looks solid, doesn't it? What you can't see on this one is there's a hole in this graph, but you can't see it because this is a computer. It's drawn by little pixels in the graphics. Okay. But if I look at this, if you look at this thing right here, I can zoom in and you can see it better, but it takes too long to zoom in. If I do a trace feature down here at the bottom, what does it say for 0 so I get to look right? At 0, it is undefined. So right here at the very peak of this thing, there actually is no answer there. It's a hole in the graph, but you can't see it. So when you graph things, keep that in mind. When we look at an equation, which is over x, and we have a fraction here where x is on the bottom, in fractions, you can never have a 0 in the bottom. So we can produce some weird things. In this case, it produces a hole in the graph because it's undefined at 0. Okay? These are hidden things about graphs that you want to be aware of. Okay? They can occur. I'm going to look at another one that happens a lot. And this is why you can use the graphing calculator to help you graph, but you still have to show graphs, neatly on your own. Okay? To overcome this one. Let me get it going here. Did it kick out on me? Well, it makes my same point here. What are you doing? Get out of there. Nice thing, no, got jacked up. But anyway, here's the point I'm making. In looking at this, it looks like the graph stops here, doesn't it? In this particular graph, this graph does not stop here. It just can't continue drawing it. That means the value is so small, it's smaller than the pixel that I can draw it with. So it can't draw it anymore. Okay? And so the calculator will just stop. You have to understand the nature of this kind of a graph that we did here so that you don't draw me this graph. If you drew this, it would be marked incorrect. Okay, you'd have to draw the actual graph, which means that this part down here continues downward forever. Okay. And here's another one I want to look at. See if I can get this one without messing up on me. So now we have that graph. It looks kind of like the one before, correct? But in this one, there is nothing wrong with that graph. That is the actual graph. It does stop right there. Okay? So that's one of the things we're going to look at is making sure we can recognize what type of graphs we have so we know what they look like so that we don't make these kind of mistakes when we are using a calculator and things like that. So a lot of what you're going to learn in here is how to use the calculator to do a lot of our work for us if possible. You also have to learn all the major functions and what they look like so that we can recognize them for models and stuff like that. So as we go through this unit, first unit here, all these things are going to happen. We're going to look at all the major functions and all that other good stuff. So there's that. I'm going to go ahead and stop the video.